Howdy, AP PreCal, it's Ms. Kosh. I am back working through Unit 2 multiple choice questions for Mr. Passwater. This is the third video, and we are picking up here. So, which of the following is equivalent? Oh, okay. Notice, okay, so here's how I would solve this problem. I see that all of these are written as powers of 2, so I'm going to rewrite this, and I see 6 or 36. This is 36 times 2 squared to the x. So it could be 36 times 2 to the 2x, or maybe I should put parentheses here or something like that. Or it could be 6 squared, but then they wouldn't have the same base. Is this an answer choice? It is. I'd call it that one and move on with my life. But should we verify? If I plug in 0 here, I get anything to the 0 power is 1, so that gives me 6. If I plug in 0 here, I get 36. So they're not going to have the same initial. They're not, like, their f of 0 don't match, so that's no good. Okay, the next one, it's a similar idea, slightly different. This is 3 times 4 to the x times 4 to the second power. Since they're being added, you can split them. And 4 squared is 16 times 3, I think, is 48. So 48 times 4 to the x, is that an answer choice? It is. We could check by plugging in 0 here. We get 16, we get 48, plug in 0 here, we get 48, so that's a good sign. We could check the others, but unless there's a mistake in the key. Plug in 0 here, and I get 9, but plug in 0 here, and I got 48, so that's not the same. Okay. Oh, this is power to a power, so it's the same idea, but it's just a different property. This becomes 5 squared to the x, so this is 3 times 25 to the x. This is not the same as 75 to the x. Here's how I would prove that to you. Here's my table. Here's my x value. If I do 3 times 25 to the x, and then I do 75 to the x, when I plug in 0, I get anything to the 0 power is 1 times 3 is 3. This is 1. If I plug in 1, I get 25 times 3 is 75. I get 75. Okay, so it's correct here, but then when I plug in 2, I get 625 times 3 versus 75 squared. Not the same. Don't know what they are, but they're not the same. Okay, so I didn't finish the problem. 3 times 25 to the x is how I would answer that question. We can check again, plugging in 0, anything to the 0 power is 1. That gives me 3. So this g of 0 is equal to 3. Here, g of 0 is equal to 9, equal to 9, equal to 1. So, no good. These are similar. They're just all kind of the same. This one is asked a little differently. Let's try that. Okay, a horizontal translation of the function g given by this. Okay, so g starts here. What did this one do? We moved it to the right 2. Which of the following? Oh, they want a vertical dilation. Okay, so we have to rewrite this. 4 to the x times 4 to the negative 2, which would be equal to 4 to the x times 1 over 16. So 1/16 times 4 to the x. So it's that one. Oh, I forgot. We taught that earlier this year. That was fun. It's been a long time. I forgot what we did earlier this year. Similar idea with this one. They want us to, notice, let's see if this works. This is 3 squared times 3 to the x. So I could write this as 3 to the x plus 2, which means I'm shifting it to the left 2. Is that a choice? It sure is. The graph of the function is a horizontal dilation, and this is equivalent to that. Oh, okay. Well, what is this? This is this square root of 3 to the x. This is 3 to the 1/2 power raised to the x, which could also be written as 3 to the x over 2, which seems to be that right there. Okay, exponential function context and modeling. Okay. What's happening here? We have, we're multiplying these by 3. So this is an exponential. My r value is equal to 3. My initial amount is equal to 10. So what I see is this looks like c of t is equal to 10 times 3 to the t. Let's check and see if I plug in 2. I'd have 9, so I'd have 90. Oh, that's good. If I plug in 3, 27 times 10 is 270. That sure better be the correct answer, and that's right here, so that's a good sign. Okay, it increases by 15%. I don't know that I want to really do this problem, but when I see increases by 15%, we were at 100%, we've added 15. So it's not these, because that would be a decrease of 85%. These are going to be increases of 15. Okay, hang on, let's see. I didn't actually read the problem. I just saw this and went from there. Okay, number of cars traveling along a busy highway in a particular running can be modeled by a function C. Fantastic. For 0 to 8, the number of cars at time t increases by 15% each hour. Okay, at time equals 0, a total of 54 cars. Okay, so the initial amount is 54. Well, that doesn't tell us anything. If t is measured in minutes, okay, which of the following is an expression for C of t? But C of t is a total number of, hang on, at time t hours. Okay, so we want to be able to put t hours. So t hours is 60 times t minutes. Yeah, if t is measured in minutes. Oh, no. The t is measured in minutes. Okay, so the number of minutes divided by 60 is how many hours, because we're increasing by that much per hour. Okay, so those slowed me down a tiny bit, but there you go. Oh, fun. My favorite, you guys, is trig. Have I said that yet? Point being, these are fine. I just don't love them. Okay, there are 7 days in a week. So, okay, let's see. And a particular sample, the amount of radon 222 measured after D days can be modeled with that function. Okay, it's a half-life problem. The initial amount times 1/2, and then D over the length of the half-life period. Okay, so a week is equal to 7 days. Oh, D is equal, what? I disagree with that. I wonder if they caught that typo and I just didn't print out the new one. Right? Am I crazy? Comment below if you think I'm crazy. Or tell me if I'm wrong on this one. Let's see. Let me read it one more time. I'm a little headachy, a little cross-eyed. So let's see. Remaining after W weeks. So here's our, so 1 week is equal to 7 days. I disagree with that. So maybe there's a mistake there. So, so that means if I want to solve for D, D is equal to 1/7 of a week. So then I would plug in, wherever there was a D, I would plug in W over 7. Anyway, we'll have to check. Maybe he fixed this and, okay, I'm kind of tired of some of these. An increase of 20, so these just require you to read carefully, and I'm cross-eyed today. My neck hurts. That's a non sequitur. Okay, let's see. At time 0, the initial value it has an initial of $215,000. So that is the initial amount on all of them. It's increasing this much per month. Okay, so it's going to do this. Oh, this is, I would do, oh, okay. What? Yeah, it's not this, because that's going to give you an exponential decay. So it's one of these two. So if my t is measured in years, how many months is that? It's going to be 12 times the number of years. So I think we're looking at this one. If I'm wrong, be nice and comment below. All right. Oh dear, I've forgotten residuals here. Come back for the next video. I need a drink of water. All right, subscribe, like, comment down below, and let me know how I can help you, and we will keep going.